Okay, so I'm James Atherton from 7digital, and I'm going to try and tell you a bit about how we've implemented search with Solr at 7digital and a few of the mistakes that I think we've made along the way, so hopefully you don't make them again. I've also got this that I have to mention. Please remember the photo contest and also conference tweets. You can win prizes from both. So keep tweeting and keep taking pictures. So who are we? Online digital content. We do ebooks, music, now in 47 territories. Power the music services on a lot of devices like Samsung, BlackBerry. Started moving into streaming with Turntable and Pure. So where did we come from with search? Well, we came from the hideous world of SQL searches, which, well, slow and bad really says it all. So we started out and we took Solr and we wrapped it in a cuddly little API so that we could more easily change that than changing Solr. Rather than having to recompile Solr, we could just make a small change in our API in the way we did our query parsing. This is here just to prove that I'm not just a cat person. So our old architecture was pretty simple. Had three kinds of objects: artists, releases, tracks. Really says it all. Some of them make music, a release, album or a single, and you have tracks on an album. So each of those objects contains the one above it. So a release contains the artist data within it, and a track would contain the release and the artist data for that track. So our first stab at Solr was back a couple of years back. We started off with artists because they were smaller, there's fewer of them. Then moved out to releases. Solr 1.4, only 17 stores at the time, mostly in Europe and the US store. Index size, everything together, was about 40 gig. We ran it on virtualized machines, KVM, and well, we're still running it on KVM now, and it's fast. We're not using bare metal, it works quite well. And we dropped the data import handler early on because we found it didn't work for us, and when we moved to incremental updates it was having issues. I think they've all been fixed now, but never really looked at that again for 1.4. And so that was our architecture. Had a couple of Solr boxes with a master going through our little cuddly API, and still all of our track search, which is one of our heaviest search endpoints, was still going through to the database, and the difference in search performance was noticeable immediately, but it took us a while to get around to doing tracks. So last year we finally got round to doing some tracks, moved on to the newest Solr we had around, 47 sorts, and we sat down at some point and we said, so do we just put it all into one index? Do we split it up? No, we'll do what we did before. It worked fine for artists and releases. We'll shove it all into one index. What can possibly go wrong? And it came out at 430 gigabytes, 470 gigabytes, about 450 million documents now. Didn't revisit data import handler, which we maybe should have done. And wrote our own ingestion process to shove all of this data out of SQL Server into Solr. One mistake of this is it used to take 7 days to reindex a server if it fell over or died. Now we've got it down to about 2 days, but it's still 2 days. So here's our current architecture, everything going back to our 4 track Solrs and a couple of artist release Solrs. It works well. It could be a lot better. Some of our track slaves are KVMs. If you're going for really large indexes, do not virtualize. Really, don't. Just go for bare metal, big bare metal. So yeah, we learned we should have split. For us, 47 shops, splitting by shop would have been by far the easiest. You'll probably have one type or one field that just makes logical sense to try and split by. Or you can, with 4x, go into sharding or however you wish to do it, but try not to do what we did and go for 400 gigabyte indexes if you can possibly avoid it, because it's painful. It just makes everything difficult. And beware your inflection points. As we found out, 400 gigabytes of data is not just 10 times 40. It doesn't behave in the same way. You can't just go, oh, it'll be 10 times slower because we've got 10 times as much data. And here's one from a few weeks ago when one of our clients forgot that they were load testing us, and instead of using their pre-production key, used their production key and just dumped a whole load of traffic straight onto us for about an hour and a half. But thankfully, it gave me this lovely graph to show you guys. So everything was going quite happily up to about 500 requests a minute. Slight inflection point, and it starts going up through 550. At 600, something happens. We're not quite sure why, but that's when load just rocketed. So I actually truncated the graph because it went off to something like 25 seconds response time. The whole cluster just ground to a halt, and it was about an hour later that it all came back down to the happy region with the first red arrow. But yeah, don't expect linear scaling. I'll get back to this later. Try and run some tests. So what do we want in our servers? Well, for what we're doing, our track ones are the main boxes. We've got 48 to 64 gig of RAM in those. I wish we had more. I've got some new servers that have probably arrived while I'm talking to you. They've been on order for 2 weeks, and they've got 128 gig of RAM. Should make my life a lot better. The fastest disks you can buy, because at some point you're going to miss cache. At some point you're going to have to hit disk. If your disks aren't fast, you see your I/O weight spiking up to 70%, and it's not a happy time. And CPUs, very much depends what you're doing. Test. For us, 4 cores works perfectly well. We're not doing anything CPU intensive, but I know some people that run on 12, 16 core machines and flatten the CPUs. Virtual or bare metal? Again, test. For us, release artists, perfectly good on a virtualized server. Nice and easy to move around, great for the systems guys. They really like it. As soon as you go to bare metal, there's no way to just turn it off, add more CPUs, add more RAM, bring it back up. You've actually got to buy a new box, migrate everything over, or re-ingest. Horses for courses. Make sure you've worked out what you need. Optimize. Oh, I did this. I had a 400 gigabyte index, and I thought, shall I make it faster? I don't need to put this master in. I'll optimize. Just before I put it live, I'll make sure it's all clean, and then we'll put it out, and it'll be beautifully optimized. It'll have all been, no, it just starts sticking every file together, and you end up with this huge file. If you're never going to ingest anything else into it ever again, maybe it'd work for you, but if you're actually continually ingesting stuff, just no. I think he says it best. And cache warming. Got bitten by this as well. Can leave a funny taste in the mouth. First searches and warming your caches. We started off with no cache warming, no first searches, and we'd restart the servers, and we'd get a whole load of 502s, 503s for service just not responding fast enough. So we added a bit of the cache warming, so fire off the last 5,000 requests that we had in cache. It was okay. We then decided to add a first searcher, so when we had to restart the JVM for out of memory or something, we'd put a few of the most popular queries in. We'd put some filter queries in there. It'd warm up the caches. And this was all going swimmingly. We'd got rid of all the 502s. We could restart a server. No errors went through to the end users. Then one of the boxes fell over under high load, dropped all of the load onto the remaining 3. One of those 3 fell over. We were trying to get the first one that had fallen back over, and we had about 120 queries in the first searcher. So we'd bring it back up, and then we had to wait 5 minutes, and then we'd bring the next one back up, and we'd have to wait 5 minutes, at which point the other two fell over, and then one of them came back up and immediately fell over under load, and then the next one came up and immediately fell under. So we just redirected everything at the master, finally brought all 4 of them back up after just going straight into the boxes and hacking down the first search warmer, brought them all back up, and now we've got about 5 queries in our first search. And in the load balancer, we've set it so it gives a nice 10-minute ramp up of load back in to the boxes. Put the master in as a final point of failure. If all the other boxes fail, just dump everything onto the master. It will probably die, but at least some customers will get some search results, hopefully. So yeah, plate warmers, a bit like first warmers, they can leave a slightly funny taste. And I've said it before, testing. Test your ingestion, data import, test it again, test it again. The amount of times that I thought, oh, the data in the database will be fine, I'll just import it. And after about a day of running everything in, there'd be one little bit of data that wasn't quite in the right format. Was somebody had put a text thing in a number field, but it was being stored as a string in the database for historical reasons. Suddenly, everything blows up. Test it. And load test early and often. We had our client do it for us, and we paid for it. Better you do it before they do it. Logging. This will be up to you. Now test this. You don't want to log too much. If you fill up your root directory, your Linux server will crash. It can be a bit of a swine getting it back up and running because it'll come up and its partition's full and it'll crash. Horses for courses, or cats. And monitoring. We found New Relic to be quite good. Gives you cache graphs, gives you average response times, can break it down per searcher. But in the end, we ended up doing a combination of the two, statsd and graphite and New Relic, because there are some bits in our code where we can just put a small statsd hook in and count exactly what we care about, not just what New Relic thinks everyone else cares about. New Relic is awesome, but augmented with statsd, we've found it incredibly useful. We also have a bit of Zabbix monitoring for the boxes to just monitor disk usage, etc., etc. We found this great. Business would come up and go, so we've got these new releases. They've got to be out in Germany. The German new release day is coming up. Has everything indexed for Germany? And we'd be forever just putting down whatever we were doing, checking on the indexers, going, ah, yeah, Germany indexed 5 minutes ago. Everything, so long as it was there then, it should all be in. Your new releases should be there. Your chart data should be there. People can buy size Gangnam Style. Excellent. And we just found that this was becoming a more frequent thing. So we decided to take a choropleth and visualize it. So this was just after we'd done a database upgrade. We'd shut down all of the indexing. By the way, red is bad. Red is nothing has been indexed for 24 hours. Blue means it's been indexed within the last hour. And green means currently indexing. It actually pulses and flashes. So this removed the need for anyone to come over and ask us, so has this territory indexed? Has this shop, is our data there? They could just walk up, look at it, go, OK, and wander off. Or they'd look at it and go, it's all red. What the hell have you guys done? You've broken everything. Why have you broken everything? But thankfully, we had a good excuse. The database had been switched off. And this was a serendipitous discovery for us. We didn't used to have a little drop down that did instant search as you type. We just used to have the old-fashioned search box. You'd type in, click through, you'd go to the search page. Still, if you don't see what you do there, you can go through to the search page, you can page through all of the results. But this came from us just testing our track search. We were typing in URLs, going off to the API, getting back a few results, looking through, and we just thought there's got to be a better way than this. So my colleague at the time, Greg Sahanic, he went off, found a bit of jQuery, found CSS of our website, put it all together into a little app to hand over to the rest of the company to just test track search and see if we'd improved it and how we could make it better. And we found that suddenly, when people were typing, the search results seemed a lot more responsive. If you just typed it all and hit enter, you'd sometimes be waiting about 2-3 seconds for the results to come back. And we were there going, I don't know what we've done. This is horribly slow. And we did this, and as they're typing, yeah, the first result may take a couple of seconds to come back, but they don't notice because they're still typing. And as they're typing along, the new results start coming back, and then it starts showing them stuff. So it seems quite responsive. The first result populates the caches with documents that match the first few letters. So then your subsequent characters populate more of the cache. And it worked really well. I think when we first put it in, we got a 25% conversion rate on album sales straight off the drop-down search. And off search previously, it had been about 10-12%. So it was quite a good boost. And obviously, there's fewer clicks. They come straight here, they start typing, they click on something, they buy it. All the better. It was just a very simple bit of jQuery Ajax. Magic deploys. Very recently, we've put CF Engine in, and if we want a new server, we install the OS, Debian Squeeze. We type a small command. It's soon going to be just press a button, and it creates a new track search server, a new release server. It starts replicating down immediately as a slave, and then we just put it in the load balancer. And it's, if you can automate your deploys, it takes so much pain out of everything. And finally, where we're hoping to go is eventually split our artist and release Solrs. Maybe do something with Solr Cloud, putting Solr Cloud in the cloud. We're not quite sure, but there's a lot to do, and I'm sure you'll have questions. And here we are, questions. And by the way, if any of you want to work in London or fancy a job in London, we are recruiting. So. The question was to talk a bit more about how we visualize our indexing. This is done with D3 JavaScript libraries. They give you nice maps that just hook in. You can assign certain IDs. And on our indexer, we have we're a .NET shop, so it's a .NET indexer. And we have a service stack API. You query the API, and it gives you a list of times that we last indexed the shop. And we store that in Solr as well, so we've just got a small indexing core that just has shop ID and timestamp for the last time that an indexing job went through. And we just continually increment that while indexing and pull back a CSV of it and drop it into D3, and you get a nice little graph. The reason it's not red and green, and it's the flashing green for the thing, is because we went through a colorblind safe color palette. The question is, did I find any magic ratio of shards to RAM to disk? There's a very quick answer to that, no. One thing we did find was not giving all of the RAM to the heap, and actually giving quite a bit to the OS to do its own disk caching worked quite well. For our use case, we played around with a few values, and we found that 66% to JVM and the rest to the OS, for us, worked quite well. But that's not to say if you get more RAM that you're just not going to leave the disk cache at the same size and just give more to Solr, or vice versa. Again, test it again. If you've got 4 servers in live, play with one of them, see how it differs from your other servers. The question's about SSDs and if we're currently using them or not, and if they're better for disk I/O. No, we haven't done any testing because they hadn't arrived when I got on the plane to come over to LA. They've probably arrived this week. just based on stats pulled off the web and stuff, they've got about 10 times, 15 times the I/O performance. So that might mean that I don't need to do as much first search warming, and I can just hit it with actual user searches, and it'll be fine. They've hopefully been set up, and by the time I get back, I'll have new boxes, and all of my response time graphs will have dropped happily. But currently, I don't know. But we will test it. Question is, how fast are our rotating disks now? They're 10K SAS disks, but they're virtualized through KVM. And if you are virtualizing through KVM, use the virt.io disk driver, not the E1000 or any of the others. The virt.io is a lot better. And also, if you are using virtualization with very high I/O throughput, make sure you watch your I/O weight and your bandwidth throughput on the virtual machines, because there's a bug somewhere in KVM or the virt.io driver or some bit of the stack we're using at least, and we noticed that after about 3 or 4 days of absolutely hammering it with disk I/O, suddenly the performance just drops off and doesn't recover, and you've got to restart the machine. The question is, I talked about the failure of subsequent machines, and what would we have done with a hard drive failure, because it sounded like we had physical machines. 2 of them were physical machines, 2 of them were virtualized, but they all run on RAID 10. So if we had a hard drive failure, it would flag up in Zabbix monitoring. So one of the systems guys would go out on a motorbike, drop another disk in, come back, and as long as the hardware RAID controller or something hasn't blown up, then we should be fine. But if some critical piece of hardware blows up, then we're probably down to 3 servers, and you just wait until the bit arrives or a new server can be found. All right, thank you very much.